Okay, hello. My name is Warski. Thanks a lot for having me. Thanks a lot for coming. I come from Poland, and my company is actually hiring as well. So we have to know Polish, so this might be a small problem. Still, if anybody is interested, let me know. So yeah, so I would like to do kind of an introduction into Spray.io. So what is Spray? I will have like 4 slides, and then there is going to be mainly live coding. If there are any questions, just ask them as we go. If it's too slow or too fast, let me know. Okay, so Spray.io. If you go to the Spray.io website, you will see that it is an open source toolkit for building REST HTTP-based integration layers on top of Scala and Akka. That's a very nice introduction sentence, right? Everything is clear. So what you can basically do with it is you can write your REST services in an elegant way. Spray is based on Akka, so that's one of the ways through which they promise to achieve high performance. So you can handle many connections at once, and you can handle many connections per second. It's based on actors, though you don't really have to see the actors if you don't want to. What is also important is that the project was kind of acquired by Akka. It's going to be one of the Akka modules in the next version. So there's an Akka HTTP preview available now containing parts of Spray. It's being ported. But Spray.io itself will be supported for some time, and then without large code changes, you will be able to move into Akka HTTP. OK, so the plan for today is to first code a REST service, then to test it, because everything has to be tested, right? And I will also, Spray also has a client component, so I will also show how we can write a client. However, the client part is going to be changed a lot in the Akka port, so I'm not going to focus on that too much. OK, and yes, before we start coding, just a little bit about me, so that you have at least some information who's talking to you. I'm a software engineer and a co-founder of Software Mill, which is a company based in Poland. We have a distributed company. Everybody is in Poland, but we don't have an office. It's kind of a flat company because everybody is a CEO, kind of. But that's a topic for another presentation, I suppose. We do a lot of Java-related stuff, either in Scala or in Groovy. Of course, a lot of JavaScript as well, to be able to do some front end. We are a TypeSafe partner, and yeah, so I guess that's about Software Mill. We are also the answer to all staffing problems in some degree. We have clients mainly from the US. Yeah, and me personally, I code in Scala for like 3 years full-time, and before I was doing it as a hobby. I wrote some open source projects like Nverse, which is a Hibernate module for entity auditing. I'm not sure if it's a good thing now to say that you wrote part of Hibernate, but maybe it is. I don't know. Yeah, I also wrote Macquire, which is a dependency injection library. If you're interested in that, I'm doing a talk tomorrow in San Francisco, Scala meetup. And I have a blog where I write about very interesting things, hopefully, and a Twitter account, yeah. And I guess that's it. OK, so let's start. So I will create quickly a new class. Let's call it Scala Bay. OK. It will be an application, so I will make it an object. OK, so we have a very simple application. Before we start coding, let's look at what kind of dependencies do we have. So it's an SBT build. There's a couple of helper dependencies, but the main ones that interest us are the dependency on Akka. So we need to add an explicit dependency on Akka actor. because Spray doesn't depend on any specific version. It just, it needs to have Akka on the class path. And then we have the three Spray dependencies. One is for the server side, so that's the server side DSL. One for the client, and one for writing tests. Okay, the rest is just to help us write some code quickly. Okay, so let's write a very simple service. I have everything written down in case I forget, and to be sure that something works. Okay, so I'm going to extend simple routing up. That's a trait from Spray, which allows us to write an application, which is an HTTP service. It's called simple, but it's actually usually all that you need when writing an HTTP service. Is what we use in production and in many applications. We will need an actor system. That's like coming from Akka, right? Because everything is actor-based, so we need a way to create the actors. And now we can actually start the server. So there's a method defined in simple routing up called start server. We have to define the interface and the port. Okay, and here we have to define the behavior of our application. Okay, so it will be a very simple application. It will respond to a GET request. If the path is equal to hello, we want to respond with welcome to Silicon Valley, right? Okay, so that's our application. Let's just check if it actually works. So we'll compile it and wait for Scala to complete that complex process of compiling. And there's an error because the actor system needs to be implicit. Because we didn't pass it anywhere, right? But the start server has an implicit parameter. And OK, so we get a message that we have bound to localhost, and we can try if it actually works. Localhost 8080/hello. Yeah, we got our message. If we, for example, try a different method, not get, we get an error, or a different path, we get an error as well, right? So our server behaves as we wanted it to behave. Okay, so now let's look what are the methods that we have used here. Okay, so the start server, that's like pretty simple, right? It takes the interface and the port, and what it does, it starts a number of actors defined by Spray, which will handle the incoming connections. So each incoming connection will be handled by a dedicated actor, and it will handle the request routing and completing responses and so on, right? So then we have the part which actually defines the behavior. And what we have to pass to start server is a root. Okay? So what we have defined here is a root. Root is the first building block. Root is a root is a type in Spray. And it's simply a function which takes a request context and does anything with it. So it returns a unit. That's a type. Right? So the request context is an immutable structure which describes the whole request. It contains all the request parameters, or the request body, the headers, the path. It also contains a reference to an actor which can be used to complete the request with some data. Okay? So we are going to use that to complete the request. As I said, it's immutable, so it can be passed around between actors without any problems. However, we can change it. So we can modify the path if we have already consumed part of it, or we can modify the parameters if you want, and so on. We can, for example, modify the response headers as well. OK, so that's roots, right? So what we pass here is a root. Now, how do we build roots? We build roots using directives. Directives, OK. Now, a directive is a directive is a way to build roots from other roots. Okay. For example, the get is a directive, right? We pass an inner route to get, okay? And we get a new route, okay? So a get directive kind of takes an inner route and returns the result, which is also a route, okay? It also does some filtering, right? So as a result, the inner route will be run only if the method of the request is equal to get, right? Similarly, path is a directive. This time, it takes a parameter, which is the path that should match, right? So again, if the request path, the first component at least, is equal to hello, the inner route will be run. So this, right? If the path is not equal to hello, the request will be rejected. And the next possibility will be tried. We'll see later how it looks. Finally, we have a directive here, complete. It's different from the other directives, like the get and path are filtering directives, so they'll filter requests allowing only some specific subset. Complete simply completes the request with the given data. We can write it in a different way. We can write a route explicitly. So we can say that our inner route is a function, so we take a context, and we complete it with a string. Okay, so like that's what I wrote here is the implementation of complete, written as an explicit route, right? An explicit route. So we define that we take a parameter, which is the request context, and we do something with it, right? In our case, we complete the context with a value. So what happens is that value is sent to an actor, which then sends it like over the network to the client. So we can write both, right? So that's like directive style, and the other was a direct route. We can, at any point, we can just take the request context and do anything with it. What is also important here is that this route for each request is run in a single thread, in a single actor, so in a single thread as well, right? So and all requests are handled with a single actor. Okay, so that's a bit like Node.js, where you have one main event loop, right, which handles all the requests. So here it is very similar. We have one main actor, which holds that route and serves all requests. We can, of course, use other actors or other threads to do some long-running tasks or some blocking tasks. We will see later how. But it's important to know that because it's a single actor that runs this route and does the initial filtering at least, we shouldn't do any blocking operations over here, right? Before doing any blocking operation, we always have to send our request, our request context or whatever, somewhere else. OK, so that's the first example, I think. Now to the second example. So I have a model ready, just some data classes, so that I don't have to run, so that I don't have to write everything down. So yeah, because we're in Silicon Valley, so the only thing that's specific about Silicon Valley is the silicon, I guess. So yes, we have a silicon trait, and these are just some data classes which we will manipulate using our REST service. So if you go to Wikipedia, you can read that there's a single crystal silicon and multi-crystal silicon, and they have various grain sizes. So yeah, there are two case classes implementing this interface, and there's just a bunch of different silicons as a list so that we can use it in our REST API. And finally, a way to convert it to JSON so that we can see results in a nice way. OK, so having that model, let's add some more behavior to our server. So far, we have only one possibility of handling requests. And now, what if we want to have two different routes that we want to handle, right? So for example, let's say that we want to handle GET requests as well, but this time with a path list all, right? And what we want this to do is we want to get a JSON representation of all the silicons. So let's just store the silicons here. Plenty of silicon. Import silicons. OK. So we will now respond with media type JSON. So there's a directive for that. And I need to choose that one. And they have very pretty names. So we respond with media type application JSON. And we complete the request with silicon to JSON, plenty of silicon. OK? So this method simply returns a string, which is a JSON. It's a representation of the list over here. I have used the same directives as before. That's filtering gets, that's filtering a path. That is a bit different because it changes the response headers, right? It changes the response headers so that they include the media type application JSON. OK, so now we have these two roots, right, defined. We have to somehow combine them into one. And for that, there's the tilde operator. And the tilde operator takes two roots and returns one root, right? So how it works is that it tries to feed the request context into the first root. If the request is rejected, it will try the second root. If it's accepted, it won't. Or if it's dropped, it won't try the second root, right? So if the path doesn't match, if the request method is different, it will try the second root and do the matching again. Okay? So here maybe a note about request dropping. It's always possible to drop a request, right? We can always write something like this, right? So we have a root where we take the context and do nothing, right? So we essentially drop the request. Okay? So this request will be matched, right? It's accepted. We just don't do anything with it. And after, I think, by default 20 or 30 seconds, the client will get a timeout response. So we can always do that, right? And it has to work this way because we could have sent the context to some actor to complete it in another thread, another actor, whatever. OK, so we have our two requests. Let's see if it works. Again, compilation always takes a while. OK, so hopefully our previous endpoint still works, and we can list. Yeah, we can list all of the silicons that we have defined, right? So we just get a nice JSON. OK, so is it clear so far? No questions? Yeah, yeah, not sleeping yet. OK. Right, and there's a lot of different directives. There are directives for getting. For caching, for authorization, for authentication, for reading headers, doing JSON-P, cookies, reading form bodies, request bodies, and so on. So there's a lot of different things you can choose from. OK, so now I guess that's the second example. And going on to the third example. So now it's going to get a bit more complicated. Now we are going to handle request parameters, right? So it's so far we had static, as a very static server. It didn't really depend what the user was doing. So one of the great features of Spray is how it handles parameters. It does so in a type-safe way. So let's add an endpoint which will allow us to get a specific silicon from our list. Okay? So we create a new root. It will be a get again. The path will be silicon, and then an int number, which is coming from Spray, details. And we want to respond. Right, so here we take an index. And we respond complete with silicon to JSON. Right, we take the silicon at the specified index and again turn it to a JSON. Okay. So what happens here is that we have defined that the middle part of that path has to be an int number, right? And this root will only match if the second component is an integer. Moreover, because we have used a special matcher in our path, Spray now expects that the inner root that we have to pass to our, right, that's a directive, so it expects an inner root. So this inner root has to be parameterized by the value of the parameter, right? So here we have the value. So that is all type safe, right? It wouldn't compile if I did something like this, because here Spray expects us to give a root parameterized by one parameter. Moreover, the type of the parameter will be int, just as we would expect, right? We could also say here long number, we could say just a string, and so on. Right, so let's see if it works. Again, compiling. Right, and what was the path? Silicon details. OK, so we can try silicon 0 details. We can try silicon 1 details. So we get the subsequent list elements. We can try silicon 5 details, and we get an exception because we use a very ugly method, which simply gets an element from a list, right? Not checking the length. So we got an exception, but the server still works. We can check it, right? So it doesn't die if there's an exception when a request is handled. OK, so these are path parameters. In a similar way, we can add query parameters. We can handle query parameters. So now we will add an endpoint for adding new silicons. So we will, because we will be adding stuff, it will be a post request. So now silicon add, OK. And now we want to, now the specific details on what kind of silicon we add to our list will be passed via request parameters. So our parameters will be name and grain size. It's going to be an int. So here we need to give like this. I will explain in a second. So our new silicon will be a multicrystalline silicon. Yeah, we have it. And name. So we have to specify the name. It's going to be, by default, microcrystalline, and the grain size. Finally, we have to add it to our list. So we will do, again, a very ugly thing. We'll change this to a var. But it's all in a single actor, so it should work without any threading problems. And we will simply add it to our list. And we will return OK. OK, so complete. Right. So what happens here? So we have defined a new endpoint. This time we only accept post requests. The path has to be silicon/add. And now we are looking at the request parameters, right? So we are expecting two parameters. The first one, name, is optional, so it's not required, right? If it's not there, the request will be still accepted. The second is the grain size, which is required because there's no question mark, but it has to be an int, right? So if it's not an int, the request will not match. And again, Spray requires us to provide a root parameterized by two parameters, which are the values of the parameters. So, and again, the types match. So here, name will be an option string, right, because it's an optional parameter, and grain size will be an int. And actually, we are using that fact, right? We are calling name get or else, which is a method on an option, right? And here you can see that a string is required. Here an int is required, so if it compiles, it has to match. And finally, we are completing the request with an OK, right? So another important thing to notice is that our behavior that we define, it doesn't have to be only roots and only directives. We can just add arbitrary code anywhere, right? Because it's just code, right? So like here, we inside before returning a root, right, to spray that will be used to complete the request, we actually do some logic, right? We add the new silicon element. Okay, so let's try.
One question.
Yeah.
So the complete directive, I'm trying to wrap my head around what. I mean, obviously it's completing the request, but more specifically, like for example, could you have taken those several lines of code and put them inside the complete directive, or would that have turned out to be a terrible thing to do for some?
I can, yeah.
Okay.
Sure. So the complete, it just, yeah, I can do that, sure. It would just, it only matters what's the result here, right? So here I can do anything.
Yeah, because it's just another function.
Right. And here it's the same, right? Once I have the values, because here I need to have the values of the parameters, so I kind of know that the request is fine, right? I don't do any filtering there. I can run the logic of adding the new silicon at that point. But I can also do it later, sure. But let's see if it actually works. You never know. So silicon add. And 2 parameters. Name, I will leave out name for now. Grain size 654. Yeah, it doesn't work because we have to add post. It said OK, so let's see if it's added. Yeah, it's over here, right? We have the default name and so on. OK, so. Now a couple of things that I wanted to show you here. OK, so the first thing is that I hope you see that building an HTTP service is quite a simple thing, right? The only thing that we really need to do here is like we extend the trait, we start the server, right? And we just provide some behavior. So doing like a very basic HTTP service is literally a couple of lines of code, right? You don't need any containers. I guess the times where we actually require to have a container to have an HTTP service are gone, but still it's not a lot of code, right? You can just package it as a jar, you can run it as an application, and you have an HTTP service, right? You don't need any annotations, scanning annotations, deploying jars, and so on. So for me, at least, it's much simpler than to understand. There's much less magic involved than, for example, in a typical, let's say, Java setting. So the second thing is that the roots that we construct here are really very simple things. They are values. So we can, because they are values, and well, sometimes, so the root is a value, but the directive is a method. So we can very easily also create our own directives. So as an example, we can create, for example, a directive which does get filtering and responds with the media type JSON. Okay? So we want to define a directive. We'll call it getJSON, right? We need to accept an inner root, which will be run. We want to return a root, actually. So we want to run this inner root only if the request method is get, and we want to modify the response headers to be JSON, right? So it's actually very simple to do. Just write get. Then we write that piece of code which modifies the response headers, and we run our inner root. And that's all there is to actually writing your own directive, right? And we can now modify our code to get the JSON. We can use the nice syntax still. Let's correct the indentation, and we are done, right? And that way, from the basic building blocks that Spray provides, we can build our own complex directives, or combine the roots in any way, right? If we have a root, it is just a value which we can combine. So for example, we can say, so that's a root, right? That's a complete root. So we can extract it to a val. So let's copy it, and let's say hello root is this. And we can just say hello root over here, right? It's just a value. It's just a method, right? In fact, so a root is sorry, not a method. It's just a function. which takes a request context and it does anything with it, right? So it's a value. We can do anything with it. We can reuse it. We can wrap it with directives and so on. So these are very simple building blocks which allow us to be combined and composed in any way. However, let's just try running it if I didn't break anything, so that we don't get into problems later. So let's see if the hello still works. It does. That's good. And the listing works as well. OK. So I talked about parameters, about custom directives, various directives. OK. Akka integration then. So that is done. OK, so now I would like to show you two ways in which we can integrate with Akka. Or not even integrate with Akka, but the goal is not integration in Akka with itself. The goal is to have some way to specify, to offload the single actor from handling all the work and maybe running some blocking operations or long-running tasks in other actors. So there are basically two ways that we can take. The first one is sending the whole request context to another actor. Okay, so let's first write such an actor. Okay, so I will maybe define it below here. So we will write a hello actor. It's going to be an actor, like an Akka actor, yeah. And we are going to define the behavior of the method, of the actor, and we are going to react to a single message, which is a request context. And if we receive a request context, we want to complete it with a hello to Silicon Valley. So nothing new here, right? Although we have to import the request context. OK, so it's an actor, right? Which, when it receives a request context, it responds. So how can we use it? So let's instantiate it over here. So hello actor is going to be actor system, actor of. So again, nothing fancy here. Just instantiating a new actor, and we can actually create two hello roots so that we can see if there's any difference in behavior. We can just say hello actor, hello actor, send context. Right. So we have defined a root here. We taken the context and we are sending the context to the actor. Right. And let's add the root to our server. OK, so let's try running that. And now actually the response will be completed in another actor, right? But we only send the context when we already know that the request matches. So all the matching is done at the top level, right? So when we are sure that when we are sure how to handle the request, only then we send out the context. Because if we did it earlier, we wouldn't be able to reject the request and try the other possibilities. OK?
How do you differentiate the two? They're both at the same path. Yeah.
That's true. That's true. So the second one would win. Still, it worked. One of them. Hello to. Yeah. OK. So again, hello to works. And hello works as well. Okay. Still, maybe not very convincing that they are handled by the different things, but we can change the message. Welcome to Silicon Valley 2. And no, that's completely messed up now. Where's the actor? Oh, it's down below. Okay. And I didn't stop that one. OK, now hopefully everybody will be convinced. Oh, there's a bug. So hello returns the first version, and hello 2 returns the 2 version. OK, that's good. It works again. OK, so that's one way. You can send the context to an actor, and you can do anything over there, right? The second way is actually integrating. So we can, here the actor kind of knows that it serves an HTTP request because it needs to know about the request context. But it, of course, doesn't have to be the case. We can also have like a business logic actor which doesn't know anything about HTTP. So we will add a new root which will tell us it's about the process of producing silicon. So when you produce silicon, you have to burn, like you burn sands, something like that. I don't know the terminology exactly. So it will tell us how much time is remaining. So it's just a very simple thing. We'll have a burn actor. And we will have a single message, which I called remaining burning time. OK. Too much paper. And receive. So when it receives the remaining burning time message, it responds with some value. So let's say that there's 10 remaining time left, whatever the unit. So like it's a simple actor, right, which just sends out 10 to whatever it receives when it receives the remaining burning time message. OK, so let's create this actor on startup. Burn actor. OK. So. Now we need a new root. We will add a root. We can call it here burn root. Burn remaining. OK. So now, we have to complete the request. So now we want to ask the actor what's the remaining burning time and send that response and send that value to the client, right? So we will use the ask pattern. So yeah, we ask the burn actor, what is the remaining burning time? OK, I will do the imports in a second. Because it's not type safe, so until Akka 3 this. We map it to an int, and finally, we map it to a response. The remaining burning time is S. OK, so hopefully, if this works, so if in response to a request to that path we get 10, right? It will mean that complete also handles futures, right? Because so the question mark is returning is a future response, right? We map it to an int because we know it's an int, and then we map it to a string, right? So this whole thing is a future string, right? So previously we were giving complete a string. Now we are giving a future string, and that is also handled, right? Futures are supported in a non-blocking way, of course, right? So whenever the future is complete, the request will be completed as well. But let's see if it works. So now it's actually not so easy to make this work because you need to add a ton of imports. So first, you need to add Akka pattern ask. Maybe not only imports, but you also need to provide an implicit executor context. You need to import actor system dispatcher, which is an executor context, and you need to provide an implicit timeout for the ask. 1 second, and to be able to write 1 second, you need to import Scala concurrent. So that's like one area I think that could be improved, maybe in Akka, so that it's not that hard to actually do the ask. But anyway, yeah. So we have our root. We just need to add it to the server so that it's actually part of the No, right, we have to pass it right to the start server. Let's try running it. No implicit errors, no implicit errors. That's good. So burn remaining, right? Let's see if the hello root still works. And burn remaining. Yeah, right, we get 10. So the future was automatically handled. So that's another way through which you can integrate with actors. A very common practice also is to spawn an actor per request. You can do it like Akka actors are very lightweight, so there's no problem in spawning a new actor for each request, actually somehow wrapping the request and doing some logic there. So you can like integrate with Akka in any way. You can also, if you like, if you want to do a database query, for example, using like a blocking driver, you can just delegate it to a thread pool and complete the request from there, right? It's, the request context is an immutable thing. You can pass it around, complete it anytime and anywhere. Unless it's 30 seconds after it started, so then it will get completed automatically with a timeout. And you can change it, of course. OK, so 2 last things. So now we will add a test. Test will be quite simple, because testing is quite simple. Let me actually create a test automatically. Yeah. So IntelliJ IDEA is great, but they still can't fix the thing that when you create a test for an object, it adds $1 here. I know that it gets compiled as $1, but still. Yes, so, where I have the test. I had the test written down somewhere. My memory isn't that good. OK, so we will create a test for our roots. So again, we need to extend some traits. I'm using Scala test, should matchers with Scala test. So that's the interesting trait, right? That's the trait. That's the trait that comes from Spray and allows us to write tests in a nice way. OK, so we have all the imports, right? That's the important one. That's the testing DSL. So writing the test. It should work. It's like a basic test that everybody should have. And now, so now what we will be testing, we won't be testing the whole server. We will be testing individual roots, OK, if they work correctly. So it's not exactly a unit test, because it does start the actors in the background, and it handles like background operations if the request is completed in another actor. But it's not also like a full integration test, because there's no, this whole server isn't started, there's no network binding, and so on. OK, but to write the test, what we have to do. First, we have to describe the request. There's a DSL for that. A very simple one will be a get hello, right? So we name the method, the path, and here we can also add body and specify headers. We can add request parameters and so on. Then we specify the root that we want to test. So it's Scala bay dot, let's say, hello root, right? No, not hello actor, hello root. That was the very simple root, right? And then we want to check that the response as a string should include silicon. So let's maybe first let's try to file it. It will not silicon. It shouldn't include that, so the test should fail. So we can see that it actually does check the condition, right? Because if it passed, it wouldn't tell us a lot. OK, it failed because our message that we are returning does not include that string, right? And if we change it to silicon, hopefully it will be green. And it's green. OK? So that's how you can write root tests with Spray. Again, I think it's pretty easy, right? You just describe the request. You specify the root. Now the root can be composite, right? It can contain the tilde operators. It can be a simple root. And then you can check here, you can check the body, the response body, response headers, and so on in quite an easy way. OK, so now in fact, two last things. So the client. So you can also write, there's like a client library in Spray. In the client library, what you do is you define a pipeline which you can use to send and receive requests. So here I have defined two pipelines. One is a simple send receive. Another pipeline is like decorated. It adds some credentials to each request. Then you can invoke requests on that pipeline by using the same DSL to construct requests as before. So that's the same get. This get. It's the same as over here. Okay. And yeah, and what you get is a future response. I'm not going into details because that's one part of Spray that I heard is going to be reworked during the migration to Akka. So while it works, it may be not as safe to use as Spray itself, because Spray, like almost all Spray code, will be able to be transposed without big changes when to Akka HTTP, and the client probably not. Speaking of Akka HTTP, like a week ago, there was a preview version available. So now which version is it? I don't remember. We can see in the build SBT. Yeah, so here's the Akka HTTP experimental. It's version 0.7. So it contains the I/O layer, so the low-level communication. It was merged into Akka 2 or 3 versions ago, so that is stable. The HTTP and the Scala DSL layers are quite new, and they are now experimental. So there are like two main differences as compared to Spray. One is that there's support for reactive streams built in. So what you get, for example, here is a reactive stream of connections. And you can also return reactive streams, and they will be handled with the back pressure automatically. So like you can complete requests with a reactive stream of bytes, for example. However, if you look at it, I mean, the ceremony here is a bit different, right? So there's no simple routing up trait yet. Instead, we have a binding feature where we bind. So we called the start server method before. Here we ask an I/O actor to bind to a port, right? So it's a bit different, this single part. But once we have the binding done, this part is the same. As you hopefully see, it looks familiar, right? It's the same DSL to define the server behavior as it was before. So yeah, so here we get a reactive stream of connections, and we can handle them with this given route. So that's an Akka HTTP preview. I guess it will be final in a couple of months. OK, so I'm almost done. I have two closing slides. So the first closing slide is Spray IO, where you can find all Spray documentation and how to integrate it with SBT and so on. Spray tutorial is at the sources for this presentation. There are like 4 steps in which you can build the application. So you can take a look. And I also have some Scala-related stickers, if you would like. However, the stickers come with an agenda. So there are 2 stickers. One is from CodeRag, which is our code review tool. So we wrote our own code review tool, and now we are using it internally. We are trying to make it into a product. We'll see how it goes. But we have a very nice motto, I'm proud of my code. So that's what the sticker says. And the second one is Scala Times. Scala Times is our weekly Scala newsletter. If you're not subscribed yet, check it out. It's a weekly mail with a bunch of Scala links. I think last week we had a comic, of course, about Scala. So yeah, I'll be giving out the stickers after the presentation. Feel free to take as much as you want. Oh, and I also have some Codebrag vouchers for half a year, I think, or something like that. OK, so I guess that's it. Are there any questions, maybe?
So it's probably a primitive question. So when you do stuff like as int take a parameter and it's not there, so what do we get on the client side, 404?
Yeah, what you basically get is, well, OK, it depends, right? So what will happen is over here, right? If the parameter is not an int, so the request will not be accepted by the directive. It will be rejected because it doesn't match. So what will happen, the next directives will be checked, right? So, and if they don't match, the whole request will be rejected, and you will get something like a 404, I guess 404. Yeah.
Assuming I would like to consider Spray for like complete application.
Mm-hmm.
And let's put templating aside. Like you can probably Spray can probably easily serve static files like HTML.
Yes, there's a directive for that.
Rest,
Sure.
All rest is done via JavaScript.
Yeah.
So that sounds reasonable, right?
Sure,
How
that's
would I,
what we do in
right.
a couple of cases.
Oh, perfect. So how would I handle authentication in this case?
OK, you can write your own directive, like authenticated. So you can do something like authenticated or secure, let's say. You can say that you require a parameter password, parameter pass, right? And now you can do, for example, it's a very primitive way of authenticating. If pass is equal to
Pass.
secret, then you can do. You need the inner root, right? Because you write a directive. Then you return root, and else you return a root where you there's a method to reject. Yeah, so you reject. Now there's like a way to do a 503 here. Yeah, that's like a case class that you have to instantiate, right? So you can just, of course, double here. So you can just, or you just drop the request so that it compiles. So yeah, you can just, write on directive that way, and then you just secure things by writing, like the endpoint that should be secure. You just do like that. Okay, and now this condition can be arbitrary complexity, right?
So all endpoints that need to be secured, now I need to bracket with
Yeah.
this thing.
Yeah. So it's like an annotation, let's say, right?
But I haven't used Spray, but from my brief look at the documentation, I got the sense that one of the strengths of these directives is you can nest them any way you want. If it's more convenient to have get at the outside, put get at the outside. If it's more convenient to have pass at the outside with get and post and put in that, then you can do that. So you could probably cluster all your secure ones.
Sure, definitely. Like you can first list all the directives, like all the paths that should be unauthenticated. Then you can have one big secure, and inside you can have all the secure. Yeah, you can definitely write. That's a very good point. Like maybe I didn't talk about it, but if we have so here, like inside get, right, we can combine the directives as well, so we can have another path over here, right? Something. Right. So like the tilde operator can be used at any depth, right? Again, it's just simple values which we operate on simple methods. Yeah?
So this is just some basic authentication, right? So does it support some SSL or some other things, certificate?
SSL, I'm not sure, but for sure there's like built-in directives for basic out. Yes, SSL is like a connection layer thing, so I don't know. But
Certificates or other type of thing, because this one, it's easy to spook, like.
right. Well, especially with our security over here. So I don't know. Probably there's like a ton of these directives. I don't know all of them. So probably yes. If not, maybe it's a good contribution idea.
And also, I don't think it's convenient to pass the password all the time for every single parameter. It can become cumbersome when you interact with the service.
Sure. Well, you need to have somewhere you can pass it in a cookie. You can pass it in a header. Right. Yeah. There are directives for reading, so you can read the headers here, the cookies, whatever. Sure. Like you can implement the secure directive in any way. Yeah.
So should there just be one file with our entire REST API defined with nested 20 levels? Is that how you organize a large application?
So the way I do it, but of course it's a matter of taste and personal preference, is I have like a number of traits, and in each trait I have a single service. So, for example, like this will be the content of one trait, and maybe I have some abstract members here which actually contain point to the main business logic, and then I mix in all the traits in my main application, and then I combine the roots like this, right? So I would have a number of traits containing the roots, and then the roots are combined at the end like this, like just writing root 1 till the root 2 till the root 3 and so on. But again, you can do it in any way, right? As long as you get hold of these vals, of course you should slice your roots somehow.
So when you're defining the roots, is it checking each root one by one?
Yes, it's going from top to bottom.
So what if I have 1,000 routes? Is it gonna add any adverse impact on how performance will work there?
I haven't tested it with 1,000. I think we have quite a lot, and I didn't really experience any problems. I mean, at some point, you probably, you can, probably if you have 1,000, you can like create a tree. So you are not like, you can like have, instead of a path A, B, C, and then again path A, B, D, you can just have a one path A, and then nest it here, right? So that it fails fast. So like you can do a small branching, right?
You can have a prefix tree, but you cannot
Yeah, a prefix tree, exactly.
You're matching the types into trees, right? Like checking parameters. So it's not that simple. So you have to organize the API.
Sure, yeah. But if you have 1,000 endpoints, then yeah.
Can you do WebSockets?
No, WebSockets, no. It's I think it's the #1 wish from the Scala users. And I think once they are done with the migration to Akka, they want to implement that. At least that's what they said on Scala Days. So I still believe them, but yeah.
Are there any tools to input generating docs, generating API documents?
Yeah, that's tricky. So because you don't really know the shape of your directives and your roots until you actually run it with a request, because it's going to be arbitrary code, right? You can have, like over here, right? You don't know when you are going to pass that or not, when you are going to actually evaluate that root or not, right? And it can be arbitrary. You can construct the roots with some in a dynamic way as well. So there's not really a way to write a good documentation tool.
And nothing with the spray runtime, say, with anything like that?
Not that I know of. I mean, how would you, if you wanted to generate documentation, I mean, probably you can wrap the context somehow so that when the application is running, it somehow documents all the endpoints that it encounters. So you can just, you could do that. But I don't think anybody did it. But maybe it's.
But that's not documentation, that's more like a logic, right?
Yeah. So you're right. But it was like just an idea how to generate documentation on the fly. Like maybe you generated documentation during this QA or something like that. Just idea how to be able to generate some documentation at all, because you cannot do it statically for sure.
You cannot do it because it's dynamically composing those things?
Yeah. So in general, you don't know, here we have the routes are quite static, right? Because we have written them that way. But here we can have a variable. We can have an if, which sometimes returns a route which matches one path, and sometimes returns a route which matches another. So this can get arbitrarily complex.
Is there any support for configuration-based injection of, or dependency injection of like custom security?
Right. So that's, I guess, it's a completely orthogonal thing to Spray. So you can inject dependencies as you wish. These are just vals. Then, like, you can have like for example, this route, it can be a def parameterized by any parameters. So that's how you would inject stuff in there, right? But Spray isn't concerned in any way with such things.
So it doesn't provide dependency injection?
No. No, it's only focused on the root DSL, the routing DSL request parsing and stuff like that.
But if you were to do the application, like Adam said, you could split it into different traits, and then you can build. Probably there's this cake pattern which allows you to build, applications out of traits. So that's what they use as for dependency injection in Scala quite often. So basically, you just have those little traits which each one handles like some subset of the URL space, and each one is configured in its own way, and then you have a big application that is assembled and configured.
Right. So what I was describing before, right? Having these in a separate traits and composing the traits, so that's like, in fact, part of the cake pattern, yes.
But more than likely, probably you'll have a overlapping security about everything, and then probably put the images without security, and just use some secure ID from the authentication.
Sure. I mean, how you compose these in the end, it's, you can also add a secure over here somehow or something like that, right? Okay. So, yeah, I'll be here if you'd like to chat. Thanks a lot.